Now let's get into revisit partial or marginal change. I think in the last graph, same graph, I talked about discrete change, right? And discrete rates of changes. And let's look at partial and marginal change. So what is partial and marginal change? That is, let's pick a location. Let's say this x, okay, here, okay, where the vertical, line indicates a certain x location, and the intersection point on the probability curve here, that point. And what we're going to do is we're going to have a tangent line. Okay, draw a tangent line, a straight tangent line, tangent to this probability curve. That is this line. Okay, this probability curve. Then what we'll get is this straight line, right? And this line has a slope. And the slope tells us the effect of x on y at that point when x is fixed to, down below here is 1. But it does not have to be here. It could be here sometimes. Then we draw a tangent line. Okay? We draw a tangent line. Then this tangent line, okay, this tangent line, okay, the slope is going to describe the effect of x, that is the instantaneous effect of x on the probability at that point. And if we look at this curve here, we can see roughly, well, there's a curve here. So the slope gonna change pretty much constantly, right? As we vary the value of x. Okay, that means the effect of x on y are different at a different point on this curve, because of curvature, right? Curvature. If this is a straight line, then the story is going to be much simpler. It is just the same effect. Okay, so that's the reason why we want to check into partial marginal change. Okay, or sometimes it's called partial marginal effect. Now here, what I'm talking about, the partial marginal effect is the effect of x on the probability, a probability here. Okay, that's the y. Okay, and let me kind of repeat. The partial and marginal change or partial marginal effect is the effect of x at a certain, the probability in this case, okay, at a certain location, a given x, okay? It's not fixed. So the partial change in the probability or Marshall effect is for Logan model. We take, partial derivative with respect to a generic xk, and we get actually, on the left is, this term multiplied by beta k, right? And this term on the left turns out to be the probability density function of the standard logistic regression. Okay, so it's expressed as lambda, lowercase Greek letter lambda x beta multiplied by the coefficient for xk. Okay? And that is equivalent of this. Okay, for probit, then the Marshall and partial change is that term. So the marginal effect is the slope of the probability curve relating xk to the probability y equal to 1, given x, holding all other variables at a fixed point, okay, because it really depends on where x is, okay, not holding all other variables constant, okay, but holding, this is a mistake that I intentionally made, okay, but holding all other variables at their fixed location, as I just talked about. And the sign of the marginal effect is determined beta k. Okay, so if beta k is positive, then the sign of the marginal effect is going to be positive. Okay, and that means, well, the effect, the marginal effect at that x location is positive. Okay? And the magnitude of change depends on the magnitude of beta k and the value of xk. Of course, we're going to take a probability density function, right? Lowercase phi and lambda. And these two quantities going to be calculated, by R if you're asked to do that. Now, let me quickly talk about measures using, following other dimensions, okay? And so in this case, I'm going to talk a little bit about global measures. So here we have two global measures. First is called average discrete rates of change. Average discrete rates of change. So if you remember, this is discrete rates of change, right? So the F here denotes some generic probability, cumulative probability density function, right? So in logit, it's going to be what? It's going to be exponential function of x beta over 1 plus the exponential of x beta. And here, delta in the denominator is basically the change in x, right? We do that for one case. So that's what's in the circle, okay? But what about we do that for every single case in our estimation sample? So that is the sigma, summation sign. And next is take an average. So that's called average discrete rates of change. Well, then people are gonna say, well, every xi is different, right? Every row vector for covariates is different. How are we going to deal with that? Well, usually when we look at average discrete rates of change, we're going to hold, we're going to, hold all other values of covariates at their observed location, okay, for every single case, okay? We don't change them. Then we only change the variable of our interest. So here is xk, okay? And then what we're going to do is, we could do multiple things. We could, fix xk, starting point at a certain point and change by fixed amount. Or sometimes, we could do is, we start at basically the observed value of xk for every single case. Then we change the fixed amount. So every case, for xk begins at a different point. Better to be, then change by a fixed amount. So there are multiple things we can do, and that is called average discrete rates of change. And usually for that one, we're gonna, change, just the values of one variable of our interest and hold all other covariates at their observed values for every single case, okay? And the next one is called average marginal or partial change. Okay? So again, what we do is we're going to calculate the partial change, right, for a covariate of interest, okay, for a single case. Then what we're going to do, of course, that quantity is going to be multiplied by beta k, right? But that beta k is the same for every single case, so I factor out, okay? Anyway, these two terms multiplied together becomes the marginal effect, right? The marginal effect for a single case. Then what we're going to do is summation. We sum across all cases, then divided by n. And we usually calculate the marginal effect at observed location. Okay, so average marginal or partial change. Sometimes we do group comparisons. Okay, and here group comparisons we don't use raw coefficients. We could use a list of and statistics we just talked about. So, for example, here there could be multiple multiple possibilities. But here, let's say group differences in average marginal effects. Okay, so in the last slide, I just talked about average marginal effects. Okay, so let's say, okay, here what I'm going to do is I'm just going to calculate the average marginal effect for group 1. That's called G1. So what I'm going to do is I calculate the marginal effect with respect to a generic variable xk that is of predicted probability with respect to, and add them together. Then average across the group size in group 1. And then what I'm going to do, I do the same for another group 0, then take a difference. Okay, so that's called group difference in average marginal effect. I can do a lot of similar things like that. For example, I can do a group difference in average predicted probabilities. Right? That's another possibility. I can do a group ratio, okay, of average marginal effect. So in terms of, instead of taking difference here, I can take a ratio. Okay, I can take a ratio. So these are all possibilities, And thank you very much.